give you a few examples so you have an idea about what we're going to be talking about here. Maybe you want to enable auxiliary charging when the battery is low. Maybe you're doing that from the grid or maybe from the generator. You may want to provide extra power during heavy load usage. So if you have a AC motor and the solar system, your inverter struggles to keep up with it, you can enable, auxiliary power inputs, again, from the grid or a generator. You can have the generator or your loads run on a schedule. You can do battery heating. Save your money on the lithium batteries with heaters and just buy a heating mat. Put it under this. You're going to get a lot more control as to how and when to heat this battery. And then a lot of load scheduling and load disconnect possibilities with the ReadyEdge, especially with the expandability with the Ready Relay. We'll talk a lot about that. So the examples we have here, up on the top here, we have a signaling application. Have a red or a green light to show from the outside of your box if the system is good or if there's something wrong with it. And then you don't have to walk all the way up to the system and open the box. You can just see it from afar. Or maybe in addition, you are just sending a basic signal to a PLC or SCADA system. Everything's good, everything's not good. Save yourself a ton of time with programming and Modbus by just having a digital input from the ReadyEdge out to the rest of your system, letting you know what the status is. Then we show some auxiliary pumping applications here. Even without a solar system or with, the generator turns on when the tank level is low, turns on the pump. When the tank is filled up, the generator turns back off. And now you have refilled your water tanks in your off-grid homestead, for example. Then we have some simple examples of load control with the modem that we may reset occasionally so that it doesn't freeze up on you. And then maybe we only need our internet satellite communications during the daytime or business hours. So to conserve battery, we turn that off on a schedule as well. And then finally, we have a generator example, which I'll talk more about later, and why we're really pushing for AC-DC converters with the ReadyEdge and with our solar systems instead of getting a full AC to DC battery charger. It's not necessary. You can save money and end up with a stronger, more robust solution, and I'll show you that later. Okay, so now I've told you about ReadyEdge. Now we're going to do it all again in some more detail. So again, we started out by talking about LiveView, the app, and Solar Connect. So LiveView, again, is our local interface that gives you local visibility, simple and fast but comprehensive configuration, and then fast diagnostics when you're on site. This is what you're going to use when you first turn on the ReadyEdge most of the time, or you'll use the app. Again, it is available on the local network via an IP address that I'll show you how to get to as well. So we're going to go into detail, but here's some basic ideas of what it looks like. So with the LiveView or with the app, we can get our alarms, faults, and notifications. And here's little snippets of different pieces of the LiveView interface telling us what our digital inputs are, showing us that we have a connected product, in this case, the Sun Saver, telling us everything's okay, more details, and then just system errors in general. Giving you all the information you need right at a glance, knowing everything's green. You don't have to look into it. You know that life is good. So now let's hit on Solar Connect again. So now Solar Connect is a web-hosted service that we provide for free. It is compatible out of the box with the ReadyEdge and with the GenStar, though you might need a software update for your GenStar if you haven't recently. And because the ReadyEdge connects to all of our other devices, all of our other charge controllers specifically, that means that all of our devices now have an online cloud IoT platform that you can use to monitor your systems. People have been asking for this for a long time. Now we have it, and we think that we've done an excellent job at bringing you what you need for our customers and for your use cases. So I'll show you what this looks like in more detail even, but suffice to say, you can set up an account in Morningstar Solar Connect. Morningstar Corp SolarConnect.MorningstarCorp.com will get you there. You can set up an account, and then you can get started with your connected devices. And then Solar Connect also brings you your alarms, your faults, and your notifications as well. And so I'm showing you basically the same information I showed you a couple slides ago, but the way that it looks in Solar Connect. Solar Connect is optimized for fleet management, so you have more succinct, faster information. But again, you have the digital inputs, your voltage inputs, your basic device connection statuses, letting you know if everything is good or there's something you need to look into, and you can always click in to get more information. Okay, so now we're going to go into some detail here. I want to look at some application examples of how we expect people to use this in the real world. And then we're going to spend some time looking at how the ReadyBlocks provide the expandability to really build out a powerful control, measurement, and analytics system for your off-grid system. And then we'll jump into some real demos with some real equipment that I have in my lab here. Okay, so I love my pictures. I want to show you guys another quick diagram here showing how 2 ProStar MPPTs are connected to the ReadyEdge for those 2 meter bus ports I talked about. Again, up to 16 devices, but I would guess that 1 or 2 devices is going to be the most common application. And this shows here 2 Morningstar ProStar MPPTs connected in parallel to the battery bus. Both connected to the ReadyEdge. The ReadyEdge sees both these devices, and you have all of the data available inside the ProStar MPPTs is now available in the ReadyEdge. Understanding your load status, different PV voltages, status, alarms, faults that are happening within the ProStars are both sent over to the ReadyEdge so that you don't have to log into the ProStar itself. It really simplifies the setup of these more complex small off-grid solar systems. It's also worth noting that a lot of our customers will use ProStar MPPTs with an EMC1. Well, instead of 2 EMC1s, you buy a ReadyEdge, you're already saving some money, and you have all of the added functionality and features that the ReadyEdge has, like Bluetooth, like the Ethernet and the LiveView 2.0 interface, which makes it much easier to see what's going on, and Solar Connect, our IoT service, making these available anywhere in the world. And then I want to jump back because I really want to drive home this idea that the ReadyEdge is excellent as a standalone device as well. So this example is again showing you how we're using a SunSaver, which does not have a meter bus port. And this could, again, not even be a Morningstar device. We're measuring all of the important aspects of the solar system using the voltage inputs here. Again, the PV panel, the battery, and the load status and voltages are all there, giving you an idea about the weather, if your panels are dirty, the state of health of your battery, whether your load is on or off, and why. And then there's other things we could do as well, such as an insulation sensor to get an idea of what the insulation level is at the site at the time, and which you can compare to the actual solar panel voltage to get an idea if the panels are dirty. And then we have the temperature input, so we can still get the battery temperature. We can still get an ambient temperature to get an idea of weather or heat inside the box. And then we have the digital inputs that are really powerful for these even small off-grid non-connected systems. But again, you know, standalone, even without a solar system, there's a lot of use cases for the ReadyEdge. I already showed you an example about tank and water pumping control, and with scheduling for generator usage, sensing whether that's levels, status, insulation levels, auxiliary charging, or scheduling other loads and power supplies. And again, it just along with a larger generator with its own integrated controller, the ReadyEdge adds a lot of features that make it very easy to get advanced generator control in an easy to use system where you don't have to set up a whole second web-based system like into your deep sea cloud or whatever generator control that you're using. And this all is before we talk about the expansion and the expandability with the ReadyBlocks. We've already showed you these, so we're just going to show you what this looks like in real applications. So the first one here is a net shunt. If you want to do SOC measurements, that's percentage-based SOC measurement on your system, well, you need to know the total amount of power that's going in and out of that battery at all times. And that's not available out of the box with a ProStar and PBT because you could have other loads connected to the battery. Well, once you add a ready shunt and a shunt into the system, set as a net shunt, there's a few other configurations, buttons to click, and then the system will start calculating percentage-based SOC, which you can then use for control. A lot of customers prefer percentage-based SOC as opposed to voltage. And when it comes to newer chemistries like lithium or supercapacitors, sodium ion, the shunt as configured as a net shunt gives you much better visibility into the state of charge of your battery using our SOC algorithm. Now, there's two channels on the net shunt, right? So we also may implement load measurements. And in this case, we have the SunSaver again, which doesn't have the meter bus connection. So we're still getting our net shunt so that we can record over a long time the status and the health of the battery. But we also have our load measurements, so we can get an idea of if loads are using more or less than we predicted, or maybe if somebody added some extra loads to the site. I'm sure nobody has ever had that happen to them before. But just in case, you have these two channels that you can use. And then I want to bring up the signaling application again, because I think this is a powerful use case for the ReadyEdge, where you have some lights on the top of your box. And I'll show you later how this could be expanded. It doesn't just have to be good or bad, red or green. You can also have a third light for low fuel level, or a fourth light for low water level, or a fifth light for loads on or loads off, or generator on. There's so many different options here that you can do. In this case, one relay has two channels, but there's a normally open and normally closed. So in this case, I'm only going to use one channel for this. And I'm going to say, if there is any system alarms, errors in the system, which is the ReadyEdge or the ProStar and PBT, then turn on that relay. So otherwise, keep it turned off. And we'll wire this to the normally closed position. Normally closed will go to green. And so when there's no errors, the green light will be on. And when there is an error, which could include low voltage, which would be an alarm condition, so faults, alarms, errors, then it will turn on that relay and you'll get a red light. So if you're driving by because you're a Department of Transportation on the freeway and you see a red light on top of the box, you know that you have to stop and check that site or alert somebody else. And you can do that either on site, or send the same information to a PLC or SCADA system, or use Solar Connect to get the same information online. And then again, let's talk about some of the load control and scheduling options. So again, we're using the Ready Relay. In this case, we're using both of its channels. And what we're going to do here with this application is we're going to use our satellite comms, and we're going to turn that off if the battery voltage gets too low. So if it's a lead acid battery, maybe below 50%, we're going to turn that off. So we've implemented low voltage control directly through the ReadyEdge. And then we also get the status of that as well in Solar Connect. So we know that the load is going off before it happens and then when it happens. And then, with modems, it's 2026, but the best way to fix most computing problems is to reset it, turn it off, turn it back on. So in order to stop our modems from hiccuping after being on for weeks and weeks or months at a time, we're going to set a schedule to turn off the modem for 1 minute every Sunday and then turn it back on, effectively resetting and rebooting the device. And that gives us a way to make sure that we don't run into communications hiccups or devices freezing. And there's a lot of different options we can do with load control, but this is just an example. And then finally, let's talk about the BMS block. And the ReadyBMS is a CAN bus that is designed to interface with lithium batteries with a CAN bus. Right now, the ReadyEdge allows you to get all of the data available through the CAN bus onto the ReadyEdge, and then available via Modbus and some of the basic parameters in the ReadyEdge itself. So mostly this is going to be SOC, right? What is the state of charge that your battery says that it is? And then in the future, we're going to be continuing to expand functionality, such as closed loop control with products like the ProStar MPBT, for example. Right now, closed loop control is only compatible with our GenStar. And for larger systems, that makes sense, which a GenStar is a larger controller. Personally, we still think that open loop control with our controllers, since they are so advanced and have so much setup and functionality built into them, that open loop control for smaller off-grid systems is sometimes the best way to go. It's important to note that, you know, lithium batteries have BMS, battery management systems, and they will shut themselves off if the system is not configured correctly, or if there's too high a voltage, or if the voltage of the battery gets too low, if it gets discharged completely. And so using, you know, our charge controllers and advanced load control with the ReadyEdge, we can wrap around all of the protections of that battery to make sure that it will never shut down, by making sure that it doesn't get too much current or not enough current, depending on the temperature, for example, to make sure that we shut off the loads before it shuts down, because the battery shutting itself down is a fault condition. It's only doing that to protect itself. It's not doing it as a favor to you. And this is a common misconception about lithium batteries, which I think is worth noting, that we will soon be having a lithium webinar that will go into great detail about how to set up lithium batteries in general, and also with our system specifically. So depending on when you're watching that, that might already be out. I'd check to see if it's there. If not, reach out to us and we'll make sure to get you signed up so you can view it live. So what does all this mean if we expand this out to a big, complex off-grid solar system? Well, we end up with a system that looks like this. We may have a generator and a pump, and the pump is only scheduled to run when the generator turns on once a day, but the generator will still turn on if the battery is low. And then we have, you know, lithium feedback from a bank of lithium batteries going into the BMS and the ReadyEdge. And we also have auxiliary or emergency charging with a plug on the box, and a bunch of TriStars for the solar side. And then we have another TriStar PWM controller for load control or diversion control, to run water heaters if the batteries are full and there's still solar available, or when the generator's on. And again, all of this is schedulable. AC inverter also, right? Schedulable, or on low voltage disconnect. And then regulated DC loads as well. So this can really be expanded to be quite complex. And then I'll show you some more examples of the signaling that you can do. System errors, generator on, system okay, fuel low, battery low, all of these things. There's a lot of options.